Hello students, I welcome you all on my YouTube channel. In this video, we will be discussing transpose of a matrix and conjugate of a. Firstly, let's look at the transpose. Transpose of, okay. We are pretty familiar with this transpose thing, as we have done this in the earlier classes. So I won't be focusing on transpose too much, just giving you a brief idea so that you just get a brush up of the concept. So see, if you are having a equal to some equal to, this is a matrix, a equal to 2 4 7 1 minus 1 0. If you want to find out its transpose means changing rows into columns, right? Changing rows into column. Okay, so see here, it is denoted by a prime. Some people used to write a t. Okay, both are similar. A prime would be equal to, now this is the first row, this would become column a transpose. This was the second row, and it would become here second column. Okay, this is the transpose of matrix, right? So see what is happening in it. It was first element a11, it has become a. It was a12, it has become here a21, right? So in this transpose, aij gets changed into aji, right? So this is the property of transpose matrix. If a is equal to aij, then a prime is equal to aj. Okay, and if order of this matrix is m by n, then order of a transpose would be n by. So this is the transpose, right? Some property of the transpose. If I transpose a matrix two time, okay, it would be equal to a again, because you are changing rows into columns, then columns again, then rows and columns, and then column will be again getting changed into the rows, and final matrix would be again same. Secondly, a plus b transpose is equal to a transpose plus b transpose. Also, if you are having multiplication of two matrix, then its transpose would be reversal, will be following reversal law. That is, a b transpose is equal to b transpose. Okay, just keep these properties in your mind. So when we will be needing this, we won't have to see back. Okay, we don't have to flip the pages. On the basis of the transpose, we again have two types of matrices. We can divide matrix, we can, you know uh, we have two types of matrices, the basis of transpose. First is symmetric matrix, and second is q metric, q symmetric. Okay, q means partially symmetric, not exactly symmetric. Okay, symmetric matrix is a square matrix. A square matrix is said to be symmetric matrix if a transpose is equal to self. this matrix is known as symmetric matrix. If A transpose is equal to not equal to A but equal to minus A, then it is said to be, this matrix is said to be skew symmetric, not symmetric exactly, because this is not equal to A but it is equal to minus A, so it is partially symmetric. Okay, so we will be calling this matrix skew symmetric. Okay, so some examples. Before I give you example, I'll tell you one thing. Since we know uh, a can be written as aij, and if A is equal to aij, then A transpose is equal to aji. So in this case, if both the matrix are equal, then we can say in symmetric matrix aij is equal to ai. Okay, this result in your mind could be asked as MCQs, or you could be asked to prove it. Okay, similarly here you see, if A is equal to aij, A transpose would be equal to aji. Okay, but it is equal to minus A, so it is equal to this matrix ij. So we can compare, and we on comparing we will come at the conclusion that aji is equal to minus aij. Alternatively, you can write it as aij is equal to minus aj. Okay, you just this thing. Okay, so now some examples of only one. See here, 1 3 2 3 4 minus 3. This is matrix. Now see, A transpose is equal to what would be, this is row, change this row into the column. 1 2 2. Now second row, changing second row into the column. 3 minus 3 4 minus 3 5. Now you see both the matrix are same, there is no difference. Okay, so A transpose is equal to, right? So this matrix is known as, this matrix is symmetric. Also you see here, a11 is equal to a12 is equal to 2, and a21, this was a12, this is a12, and this is 2a1, both are same, so a21 is equal to 2. This is equal. So which is the property of metric matrix, that is aij and aji in case of symmetric matrix. You also see this element, this is a13, a13, and this is a31, both are equal. Also check, and this is a23, this is a32, both are equal. So in case of symmetric matrix, aij is equal to a. Example of a skew symmetric matrix. In skew symmetric matrix, diagonal elements are always 0. I'll tell you with proof why it is so. 0 1 3 minus 1 0 5 minus 3 minus 5. Okay, this is a, A transpose would be equal to 0, 1, 3, and minus 5, minus 1, 0, 5, minus 3, minus 5. Okay, so see what is minus a. Minus a is equal to 0. So see here, a is equal to this. If you multiply all the elements with minus 1, so you will be getting minus. Okay, so it is minus 1, minus 3, 1, 0, minus 5, 3, 5. Now look at minus a and a transpose. Both are same. Therefore, we can write a transpose is equal to minus a. Both are equal. Therefore, this matrix A matrix is Q metric. The example of Q metric. Also, you see, and as I told you in Q metric matrix, see, this is A21. This is A. This is A12. This is A21. Okay. See the relation. A12 is equal to minus A21, and this also, this is equal to minus this and this. Therefore, in Q metric matrix, Aij is equal to Aj, as I told you earlier. Now I would like to tell you why a result very small on skew metric matrix. Prove that in Q metric matrix, the diagonal elements are always 0. Okay. Proof. Let A is equal to Aij is a Q metric matrix. Therefore, Aij is equal to minus Aj. This implies, see, what are the diagonal elements? Diagonal elements are A11, A22, A33, up to so on. These when where number of where columns and rows are intersecting each other, such at the junction of such point lies the diagonal entries. So these are diagonal entries. Okay, so therefore we can write, when for diagonal elements, this property should be obeyed by these elements. So II must be equal to minus Ai. This implies 2 Ai II is equal to, which implies 2 cannot be 0. It means Ai must be equal to. This implies diagonal elements. So this is diagonal. This is Ai is diagonal elements. Therefore, diagonal elements of the Q metric matrix is always 0. Now, we would be probing a result, one more result, right? It says any square matrix, any square matrix can be expressed, can be expressed as the sum of sum of symmetric and symmetric matrix. Okay, pretty simple, not a big deal to prove this result. You can prove it by yourself also, but just giving a brief idea because you have done this earlier, so I'm just brushing up your concepts. Okay, so see, if we take two matrix, okay, one matrix, let firstly let A be a matrix, A be a square matrix, okay, and we have to write this matrix as a sum of Q and symmetric matrix. Okay, so let, so from this matrix I'm going to make two matrix P and Q. Okay, P is equal to half of A plus A dash and Q is equal to half of A minus, okay, writing this A transpose first, okay, and Q is equal to A transpose minus A. Okay, so see here, what would be P transpose P prime? It is equal to transpose of whole. Since we did A plus B transpose is equal to A transpose plus B transpose, so it would be A transpose transpose. Okay, firstly this, it would be A transpose transpose A transpose. Okay, so we did A transpose transpose is equal to A itself, so we can write this would become A plus A transpose, which is equal to, because we can interchange these two, so it is equal to, we can write A transpose, we know A plus B is equal to B plus A, so it is equal to P again, so P is equal to half into this, so P transpose is equal to P. So we came to know that this P is symmetric matrix. Okay, now CQ, what happens at Q, if we take its transpose, it would become A transpose minus A transpose transpose minus, it was transpose, okay, minus A, so transpose, so it is equal to half of A transpose transpose means same A, so minus minus A. So taking this minus outside, you will be having minus half A transpose minus, which is equal to this thing, this is equal to Q, okay, and minus, so therefore Q prime Q transpose is equal to minus, this matrix is Q, okay. If you add these two matrix P plus Q, what you will be getting, okay, one second, you just do one thing, uh if you write in this way p plus q would be equal to something different. Okay, you just need to do what you write in this way. Okay, again the case will be the same. Okay, this would be symmetric matrix and this would be q symmetric, and then when you add these two matrix, okay, you take q is equal to a minus a prime. Okay, and p is equal to a plus. Okay, and then you will see this would be same, and it would be bit. Okay, it would be also q dash would be also equal to minus q. Okay, so p would be symmetric in this case too, and q would be symmetric, is q symmetric. Okay, so now if you add this, you will be getting half a plus half a. Okay, a prime, it would be getting cancelled. Okay, so it is equal to a, so thus a is equal to p plus. So thus we are successful in expressing a as the sum of two matrix p and q, where p is the metric matrix and q is the q, right? Now let's do a problem on this result. Press press the matrix matrix a as the sum of as the sum of metric and skew symmetric. Okay, where a is equal to where a is equal to 4 5 6 minus 1 0 2 1. Okay, so as we know how to express a as the sum of the two matrix. Okay, solution. Here you see a is equal to this. Now find p. P is equal to half of a plus a transpose. It would be equal to half of 4 plus sorry 4 5 6 minus 1 0 1 2 1 2 plus a transpose. A transpose is 4 5 6 minus 1 0 1 2 1 2. Okay, half of this sum. Half of 4 and 4 8, right? This would be 4 and 8 again, 6 plus 2 minus 5 plus minus 1 plus 5, it is 4 0 plus 0 0 1 plus 1 2 2 plus 0 sorry 2 plus 6, it is 8 1 plus 1 2 2 plus 2. Okay, hopping this matrix, so it would be 4 2 4 2 0 1 4 1, right? Now similarly find out q. Okay, q is equal to half of this. Okay, so it would be half of, you see what is a A is equal to 4 5 6 minus 1 0 1 2 1 2 minus A transpose 4 5 6 minus 1 0 1 6 1. Okay, so it is equal to half of 4 4 4 minus 4 0, and this would be 6, this would be 0, 6 minus 6 minus 1 minus 5 minus 6, 0 plus 0 0, 0 minus 0 0, 1 minus 1 0, 2 minus 6 minus 4, 1 second, we did something wrong. Yes, it was not 6 here, it was 2 1 2, right? 2 1 2, so it is 6 minus 2, which is, it must be right. Now 1 minus 1 0 and 2 minus 0 in. So see, this matrix is, you just calculate here, P transpose is equal to P, here you calculate Q transpose is equal to, right? And also you see, if you add P plus Q, it would be equal to, what is your, just half it, 0 3 2 minus 3 0 0 minus 2 0. Okay, what was P? See here, P is 424 0 1 424 424 201 and 201 and 412 0 plus Q is 0 3 2 minus 3 0 0 minus 2 0 0. Okay, it is equal to, adding these two, 4 plus 0 3 plus 2 5, 4 plus 2 6, 2 minus 3 minus 1, 0 plus 0 0, 1 plus 0 1, 4 minus 2 2 2 1, and which is equal to A. This is equal to, this is nothing but A. Therefore P plus Q is equal to, so we have expressed A as the sum of these two matrices, where P is the symmetric. And okay, so this is it for today. In next video we will be discussing conjugates, conjugate of a matrix and conjugate of a